Hi there, and welcome to our first episode in our C2 chemical resources, and today we're looking at the structure of the Earth. Now, if you have any problems and want to contact me, you can email me here, or if you're ultra technology, you can try tweeting me as well. Anyway, here are your objectives. So, looking today at the structure of the Earth, by the end of this lesson you should understand how the structure of the Earth is split into layers and plates, and how the plates are able to move to form different types of land formations. Okay, so the structure of the Earth. Now, the Earth is a sphere, which means it's a 3D round ball. Now, the centre of the sphere is split into different layers. Now, the first layer is the core. Now, the core is split into two, with it having an inner core here, and then outside of the inner core we have the outer core. Now, this takes up roughly half of the Earth's radius. Now, after we have the outer core, we have the mantle. Now, the inner core here is mainly made up of iron, with a little bit of nickel in there as well, but this is what makes the Earth magnetic. Now, the mantle here is mainly made up of liquid rock, and it's in here that we then have our fourth and final layer, which is the lithosphere. Now, the lithosphere is solid and it floats on the surface of the Earth. Now, the lithosphere varies between 10 and 100 kilometers in depth, and it's made up of two types of plate. It can either be an oceanic plate or it can be a continental plate. Okay, so that's how we spell lithosphere. We've also got the mantle on there as well, so let's get that in, and then we've got the inner and outer core. Okay, now the way that tectonic plates are on the surface is quite important to how we get the various different formations. So what we'll do is we'll look at those now. Now, tectonic plates are formed on the surface of the Earth, and they're believed to be solid, which are floating on a liquid. Now, here we've got the solid lithosphere, and underneath we've got the mantle area here. So let's just move this up a little bit. Now, this is liquid, and what we've got coming from underneath is we've got heat coming from the core of the Earth. Now, what this means is we have varying different temperatures below the Earth, and this means that we get convection currents. So you'll have probably done these in one of your physics topics. So we get currents that move around like this. Now, if we've got currents that carry on moving around here, what will happen is this plate here has the ability to move along here, and this is how we can get various different formations on the Earth. Now, here what we have is two plates. Now, on the left side we have an oceanic plate. Now, the oceanic plate is different to this one here, which is the continental plate. Now, you can see here that at the top we've got water, whereas this is all land. Now, this here is a very, very thin layer, but it's very, very dense. Now, as the two move together, what happens is that the continental plate will start to move underneath, and that will cause the continental plate to rise up. So the oceanic plate goes underneath, and this is where we get something called a subduction zone. Now what can happen here is we can get little fractures and breaks in the continental plate, and this can cause magma from below to build up, and we can end up with volcanoes forming. So we have one layer, then we have another layer, and so on. Okay, so we keep getting these volcanoes building up over here. Now here we're going to look at how two things can actually form in where two plates move apart. Now here we have two oceanic plates which are side by side. Now what's happening is we have one convection current moving like this, and the second one moving like this. Now what that does is that causes this one to move in that direction and that one in that direction. So that will move a little bit, and then that will move a little bit. Now what that means is we've got a gap where the Earth was connected. Now we have to remember that there is a seabed at the bottom here. Okay, so at the bottom here we do have a seabed, and what happens is we can, as they move apart, it creates a space for the magma to move up. So the magma is able to come up here. Now what this means is that we get a layer of rock forming as we get that warm, hot, molten rock forming into a solid. Now again, they move apart a bit more, and we get another layer, and then they move apart again, and we end up with another layer. And you can see now that we're starting to breach the surface of the water, and this is where we get volcanic islands such as the Hawaiian Islands. So here we've got that build up where we can actually start to grow lots of things and actually live on the islands. Now one of the problems with this is that we do have that potential for the volcano to erupt. Now we can predict when they're going to happen, but it's not very accurate, so we need to be very careful and we need to study what's going to happen. Now the lava that comes out can be very fast and very runny. It could also erupt as thick and violent and have devastating effects on those that live nearby. But people still choose to live here because the land here is very fertile and it's very good for growing. Okay, so we have a really nice diagram of a volcano here, and what we can have happening is the magma can come up through and it can erupt from the top of the rock here. Now this means that the lava can flow down here. Now we have to remember that the temperature underneath the rock is really very hot, and then it comes to the surface where it is a lot cooler. Now what happens is eventually this rock will solidify. Now because it's a lot cooler out here, the rock will form crystals, and these crystals will be very small. Okay, so you get small crystals when the rock cools quickly. Now because we've got this fracture in the rock here that allows it to escape, we can get other fracturing inside, and this is where we can get pools of rock forming in here. So the rock the lava, comes out, and we get pools of rock here. Now this is obviously a lot warmer under the ground than it is on top, so this will form a lot slower than this stuff here. So because this rock forms more slowly, we tend to get a lot bigger crystals from it. Okay, so let's review what we've done today. We have looked at the structure of the Earth in terms of the layers that we have. We have the inner and outer core made of mainly iron. We have the mantle layer, and then we have the lithosphere on the top. We've looked at what happens when we get a subduction zone, so when the more dense oceanic plate goes underneath the less dense continental plate, we get fractures and we get volcanoes. We've also looked at what happens when two plates move apart, and then you can get trenches and volcanoes being formed there. And we also looked at the formation of volcanoes and the terms of the crystals and how we get big crystals and small crystals. Anyway, I hope you've enjoyed this, and I'll see you next time. Bye bye.